All right, suppose a store has a 50% off sale on a $20 shirt, and then you also have a $3 coupon. Does it matter which discount is applied first, excuse me. All right, so let's try it both ways. Let's do 50% off the $20 and then take the $3 off coupon. So 50% times $20 gives us $10. If that's taken off the $20 minus 10 leaves you with 10. And then take the 10 and subtract 3, we get 7. Okay, so that's doing the 50% off first and then the $3 off. All right, so now let's do it the other way. If we do $3 off first, 20 minus 3 gives us 17. And then if we do 50% off 17, multiply those together, you get 850. And so 17 minus 850 is 850. So first way landed us with $7. The other one, the total was $850. So it does in fact matter. So these are two different functions that we're putting together, we're composing together. So now let's kind of do a broader definition of this. Given two functions, f and g, where x is in the domain of g and g of x is in the domain of f, then f composed with g of x is the same as putting the x into the g function and then putting that into the f function. So notice that the order on both sides of the equations are the same. So we've got two different compositions of functions here, f of g of x and then g of f of x. So this is a picture of what's going on for f of g of x. We put x into the g function, we get g of x out, and then we put that g of x into the f function, we get f of g of x out. Putting those two things together, we can build a new function where f composed with g. Alright, so let's look at some examples here. Alright, so example 2, if we put 1 into the f function, what comes out? So track with me, 1 put into the f function, 2 comes out. So now we're looking at g of 2. So now put 2 into the g function and see what comes out. That gives us 3. So g of f of 1 is 3. Alright, on this next one, f composed with g of 1, that's like putting 1 into the g function and then putting that into the f function. So 1 into the g function gives us 2. So now we would be looking at f of 2. Now put 2 into the f function, that gives us 4. So notice that the order does matter when you're composing functions. We did not get the same thing when we put 1 into the f function and then into the g function as we did doing f composed with g of 1. Now let's put 2 into the f function. We get 4 out. And now we'll put 4 into the g function. Ooh, this one's not given to us, but we do have this little example of what happens with the x's. If you put something into the g function, what comes out is 1 more than that. So if we put 4 in, we get 5 out. 1 more than that. Alright, so that's how it looks like with the mapping. It would look similar with tables. Now let's look at with equations. Alright, so this first one we're just evaluating f of 3. So put 3 into the f function. So everywhere there's an x, we're going to put 3. And so f of 3 equals 2 times 3, which gives us 6. Next, let's put 3 into the f function, and then we'll put it into the g function. So putting 3 into the f function, we already saw that, we got 6 out. So now let's put that 6 into the g function. The g function is x minus 5, so 6 minus 5 gives us 1. So g of 6 is 1. So g of f of 3 equals 1. Now let's put 3 into the g function. So the g function just subtracts 5. So g of 3 would be 3 minus 5, or negative 2. And then put negative 2 into the f function. The f function just multiplies by 2. So f of negative 2 is just 2 times negative 2, negative 4. So if you want to rewrite it as the beginning, f of g of 3 equals 4, negative 4, excuse me. Now, question is, does g of f of 3 equal f of g of 3? Well, these are the two problems we just did. So g of f of 3 is 1. F of g of 3 is negative 4. Are those equal? No, they're not. So we'd say no. All right, number 9, g of h of negative 4. Or g composed with h of negative 4. Put negative 4 into the h function. The h function is a little bit more complicated. H function we multiply by negative 3 and then add 1. See if you can track with me. Negative 4 times negative 3 is positive 12. 12 plus 1 is 13. So we're putting 13 into the g function. G function just subtracts 5. And so we get 8. All right, this next one we're going to put 0 into the g function. And then we'll put that result into the h function. G function, just subtract 5. Zero minus 5 is negative 5. And then put negative 5 into the h function. We got to multiply by negative 3. Negative 5 times negative 3 is 15. 15 plus 1, 16. Man. So h composed with g of 0 is 16. All right, let's see. Number 11, we're composing functions. We're building a new function, excuse me. So put the g of x into the f function and see what comes out. So we're building a new function, I of x. So we're going to put g of x into the f function. G of x is x minus 5. So everywhere there's an x in the f function, we're going to replace it with x minus 5. So in the f of x function, we've got 2 times x. So we will have 2 times x minus 5. And now we can distribute that. And so our new function I of x is equal to 2x minus 10. Hope you've enjoyed this video. I'll see you next time.